Hello friends, welcome to TechnoPoints. This video is an explanation video of the project which you have built, this To-Do List Android application. In this video, we are going to see the higher level understanding of how the code is structured. Whenever you will be working on some another your project, then that at that time you will follow the same structure so that your code should be more maintainable, and as your application user base grows, you will be able to easily add the other functionalities without disturbing the your whole lot of code of your application. So coming to how you can download this project. So those people who are already in the WhatsApp group, I have already shared the link in the WhatsApp, so you can just clone the repository from the GitHub and start watching this video. But the people who are not in the WhatsApp group, so they might not have that link, so they can just raise a request to join the WhatsApp group, and you can just join the group and get the link from there and start continue watching this video. The invite link for the group is you can find in the description box itself, and you can join there. So in this video, technically we are not going to understand in any concept in deeper in this video, but yes, you will be understanding how to structure the code. We are using the MVVM architecture pattern in this project, and we are exactly going to see how the files are organized and how the code is structured. Because even if we know the most advanced concepts of Android, but we should also know how to structure our code so that it becomes more maintainable, and we can start building more maintainable and robust applications for our end users. So let's get started. So here I am in the Android Studio project, and in that to-do list application project. So as we have already discussed, we are going to use MVVM pattern in this application, model, view model. So you can find the folders here, model, view, and view model. So let's first understand how we are separating the layers. Basically, we have created a simple package here with the different names, model, view, and view model. So the view layer is basically whatever we see on the UI, that all goes to view package, that is view layer. So here are some adapters and some main activities, some utility file which is related to the UI management, and the fragment which we are going to use. So all these things are in view. And opening to the model, in model for that we are using the room database in this project. So whatever the regarding the data access objects, the database files, the entities, all these things are all the things comes into model layer. So this repository and data type converters also, that all comes under model layer. And now coming to the view model, we already know that view model serves a bridge between view and model. So we have two files here, main view model and main view model factory. So we need view model factory for this project, as we are accepting some parameters in our view model. So we need to convey the compiler that how it should initialize the view model instance. So that's why we need this factory. So all this so this is the architecture style of this application. Now coming to the dependencies, let me open. So this is the section we have to edit. So from this, all these things we have added later. So this is basically a room library version 2.6.1, and this is the um, room related dependencies. This is the annotation processor. So if we are using the Kotlin annotation processor which we are using in this tutorial, then we need to add this dependency as well. And these are for Kotlin annotation processor kept, and whenever we are adding these dependencies, we also need to add the id Kotlin kept here in the plugins itself. It was not present in my project by default, but for some projects it is present by default. So if it is not there, you have to add this line. And here we are using the coroutines. So because whatever the insertion, updation, deletion, all the operations of the database, that should be handled on the background thread. So that's why we are launching a coroutine there. So we are launching a different one, is a view model scope and one is a lifecycle scope per dependency. So these are two coroutine dependencies, and this is a latest version of the coroutine. So that is about dependencies. Coming to the view, these are the different layout files. This is the layout activity main file, this is a dialog file, this is a fragment layout, and this is an uh, item of the recycler view. We are using recycler view in this. So I think you have already downloaded the project, and you must have opened it at least once and tried running it on your device. If not, let's see how the project is there. So this is our project's UI that we have built in our to-do list app. So this is the basic simple implementation. The main motto of this project and this video exercise is to understand how to structure the code so that we can uh, make the same structure in our code as in our project as well. So this is the code in which I have already added the three tasks, first, second, and third. I am going to add a fourth task as well, my fourth task. And here I will select a date, which I will select the today's date, and I click on add. So as soon as I click on add, here the toast is shown item added, and the this item is added here. And when I long click on this one, I am able to edit this. So in case of this task, I write task 1 and click on add. So this task is, you can see, it is updated. And I can also click on check mark so that it show the toast that item mark is completed. So as we are using the room database, so these check marks persist. So I let me go to back this application, and I'll also kill the application from the recent tabs, and we'll open it from again. So this checkmark persist because when we are going to click on this one, we are actually updating the database, updating the table and the entry regarding this particular item. And we can also delete this item. So I'll just click on this bin icon, and the item gets deleted, and we get the confirmation that item deleted. So this is what the application is built, and these things these simple things this application can handle for now. So that is about the running our project. So here are different layout files that we have already seen. So let me go to first one by one for all the layers. So I'll go first on the view layer. So I'll double click on this main activity. So if you see, main activity doesn't have any code. Yes, main activity. When at first, when we are just start, I mean, when I was in very initial stages of learning Android, there was main activity was very full of code in my own projects, but that is not longer the case here because we are going to use the fragments. So let me show you how it is integrated. There is nothing to see in this main activity; it is just default code. So I'll just go to related activity main.xml file, and here you can see, here also you are not able to see anything. There is just one layout, fragment container view. So basically it is a fragment container view that I have implemented in this activity so that multiple fragments can reside in this. So we are using some library from Compose related to navigation, which is a very optimal and easy to use approach that I have found. For that, I have just created here a navigation library. So just we just have to click here on rest new, and okay, I think it's gone. This dialog appears, and you can just select your navigation here, and you can name your directory anything, and you can just click on OK. The dependency will be automatically added to your Android project. And once that dependency is added, you can just right click again on this one and create a new navigation file like this one. Add new navigation resource file. You can just give it a name of your choice. That's what I have done for this file, navigation.xml. And in this, you don't have to deal with any coding. Yes, because you whatever you can just click on this new destination, and here you are able to see. I am not seeing anything because I have already only one fragment file, and that I have already added here. So the files you have already added won't be shown here. Other files you will be able to see here, and you can just navigate from this file to another file using this uh, arrow keys. So that is a technical point for another tutorial, but this is just the thing that I have used in this project. So this makes the navigation very easy. And after that navigation, okay, I have come here. So this has been explained, activity main. So I am closing this one again. uh, whatever the fragment is residing there, it is a to-do list fragment. So let's go to our UI for better understanding. The UI you can see like this one. This is the UI here, and we are seeing the exactly on our application as well. This is basically recycler view. You can easily have an idea that recycler view is actually used here. This is the recycler view, and this is just a constraint layout, and we are using a data binding here. That's why layout tag is there. And this simply recycler view, and this is a floating action button. So the button is here, that is floating action button. And here we have layout resource file for the individual item that we generally create when we are creating a recycler view. So we need that file. So this is that file of the individual item, which have all the layout things. So you can go through this all this code, and you can easily understand. We have used the uh, card view, we have used the checkbox here, a text view, an image view here, image view for the bin icon, and we are using the images from here drawable folder. This is a add icon, this is a delete icon. So these two icons I have added explicitly for this project to work, and these two were already present by default. So this is the layout file, and in this basically we are using a MVVM pattern. So we need view model for this one. So we are initializing a view model here, and we are also using a binding instance for the data binding library, and we are executing all the tasks as soon as so this is about the view. So for understanding these things, we'll first go to our go to understand the view model, then we understand this one. So I'll double click on this main view model. This is the view model file, and for the simplicity I have already added the comments here also. So what this class is for and what it does, so it will be better for you to understand. And this is a view model class which accepts parameter as context. So as we are accepting one parameter, we need view model factory for this. If we are not accepting any parameter, then the compiler automatically knows how to initialize your view model instance. But if we are using at least one parameter, we need to explicitly create a factory for this. And for this factory, there is nothing more. I have already written that it is just a bit of boilerplate code and nothing else. We just have to change this return statement with our view model view model class and cast this as t. So this is only the thing for the factory. And in the view model, basically view model is responsible for performing all the business operations. All the request comes to the view model, and the view model serves the request, and whenever it needs data, it goes to model layer and get the data, and after it is ready, it publishes the result. That's how MVVM pattern works. In the so there are different functions here. As soon as we are initializing this view model instance, so in the init, like init block, uh, we are initializing the DAO instance, data access object instance, and here repository instance as well, because we need these instances when we are calling some functions of view model. So this is a function to-do list. So it returns the live data. So live data is one of the concepts that I have already talked about in the MVB architecture video itself. And live data basically uh, create the observable, and to which the view keeps observing and update the UI accordingly when the new results comes. So we are using the live data here, and all these functions are there. So view model, when the request comes to here, let me go to main fragment, and here what I am doing, view model dot get to do list. So this get to do list is returning a live data here, and the live data I am observing here, and this is the life cycle owner. So in this code, whenever the live data changes, the controls comes here, because as soon as the view model publishes the result, the view is there to observe. We can see here it is observing. So as soon as there is some updated results, this code is executed, and in this code we are just resetting all our list and again applying the adapter. so that our list gets automatically updated when we add new item. That's you already saw. And this second is okay, let me not go to second one. This is a upsert operation, that is insert plus update, that is upsert. This room library has come up with another annotation, that is upsert. Previously it was insert and update, now an upsert operation is there. So advantage is using that annotation is that if we have already item the similar item with the similar id, and we have some fields change, that is updated the item, then if we are using this operation, then it automatically updates the same item. So we don't need to write different queries for insert and update. So all of the two things can be handled in this itself. And here we are launching a coroutine, because this is the upsert operation, that is insert plus update operation. This operation should run on a background thread because we are dealing with the database. So that's why we need to launch a coroutine. So we are using here ViewModel scope.launch, and the dispatcher is IO because this is an IO operation. And under this we can uh, call this function, so that it should be executed in the background and in a asynchronous manner. Same for delete also. We in the delete we are accepting a to do item parameter, and this to do item is basically we are sending it to the repository and asking repository to delete it. And this is also marks task completed when we click on the checkbox. That when I click on this checkbox, it shows that item marked as completed. Actually these things happens in the background. We are launching our coroutine again here, and we are asking repository to update this task completion status, and we are passing the id and is complete value. If it is true, then false. If it is false, then it becomes true. So this is the thing. Okay, one thing you might ask for, or you might have doubt on this one, that we are launching coroutines for every of the other function while dealing with the database, but for this get query we are not using coroutine, because there is no need. If you are using the live data, then we don't need to launch a separate coroutine for that. We can just write the code on the main thread itself, and the room library will automatically adjust itself according to the live data. So on the main thread also it can run. uh, there is no need of launching a separate coroutine here. And as we are already here, let me go to the to do now. So this is just not now to do item. So this is just an entity class. We already know that in the room, whatever the table we have to use in our application, we need to create one data class and annotate that with entity, so that the room will know that this is another database, another sorry table in the database. So we have already declared these three values here: task name, date, and is completed. And here is primary key id, which are not displaying anywhere. It is used internally to perform the CRUD operations. So this is null by default, and we have set it as auto generate equals to 2. So this is about to do item, and this is about the main view model. And view model factory I have already discussed. So let's go to our model layer. In the model layer, there is a data access object DAO. We have already seen in the room library tutorial that there is one data access object in the room where we declare all our function. It should be an interface, and the implementation is will be provided by the room library in the form of annotations. So we just created this operation and just annotated this with query, and just write our query there, and that's we are done. The room library will do all the background tasks for us, and will execute this query on our database, and we are able to get the result as a live data from the list. So room is able to directly uh, send the uh, live data type from whenever in case of select query. So here is a get to do list, insert to do, delete to do. This is the same. These things are not returning anything. We are just annotating this with upsert. I have written here insert, but you can just replace this with upsert. It is taking a to do item. This is also taking a to do item. Delete. So this to do item will be deleted, And here is one update query. So for the update, we we are written a custom query here. Update to item set is completed equal to it's completed, where id equals to id. So we are taking two parameters, id and is completed. So we are asking database to set the completed status to this whatever we have received, and where the id whatever the id matches of the items which we have received in from our application as a parameter. So this is about to do DAO. And to do item we have already seen. To do database, we can see, yeah, just let me double click on this one. So this is basically database class, which this class also we have already seen in the room database. So I have already written that uh, we use this we create an instance of this class, and through this class we access the data access object DAO. And again which from the DAO we are able to access the different functions we have defined in our DAO interface. And this is an abstract class again, and we are not going to provide a separate implementation for these methods. And here we have used companion object, so that we can directly uh, get the instance without creating different objects. We can get the instance of single instance of that one. So we have created a one instance variable here. So if that is null, then Zoom database instance will be separately created, and if it is already created, then we are not going inside this, and we will be returning the same instance. So this is about database. There are two things that are important here. I have annotated with the data at the database and type converters. In the database, we generally uh, declare all our entity classes here, and the version is 1. And it's the type converters that we have also already see in our Loom library tutorial. So the type converters are basically, uh, let me go to the type converter dot class. So type converters are basically when we have here a date as a parameter. So we also set a date for this one, when these two tasks we are expected to do. So for the date, we cannot directly save date format in our database. So for this we have created the type converters. So these type converters basically uh, convert this date to long data type, and this long data type is then saved to a database. And again while retrieving, this reverse operation is performed. The long value comes here, and it is converted into date, and the date value is outputted to us when we made a query. So this is the benefit of the data type converters. So this is also part of model layer, and we have to declare this here, so that the room database will know that type converters are also there, and we can use those. And similar happens for the entities. We have to define all the entities here. So this is about the database class. And for the repository, basically repository, if you see here, repository is basically, you can find that it is just a redundant of what we have created in the todo DAO. For the true DAO also, we are just doing this thing itself, and for the repository also we are just calling the todo DAO dot get to do list. So you can ask, you might come up with a question that if you can directly access the methods of todo DAO from our todo DAO instance itself, then why we are using the repository class? Basically, up to certain limit we can do this, but as we are going to as we are assuming that our project is going to expand, and we are going to add a lot more functionalities to this project. So let's say tomorrow we are going to add another functionality, that is cloud backup, cloud database, cloud backups here. So in that we need to collect all the data what we have, and we need to upload that data to the server. So or vice versa also we can do, we can get uh, the data from the cloud. So all these operations, that all operations are network related, and this to do DAO can contains only operations which are related to the database, which are related to the room database. So at that time what we might have to do, we might have to create a separate file for this for the uh, uh, for all these cloud backup cloud operations, we need to maintain two files. This file, this one instance, and another instance is for this cloud related operations, this another, because that is whole different. The retrofit interface will come there, and other all these things will come there, and the basic code we will write, it will be written there, and we need to access whenever we are going to write some functions from the view model. Let's say we have created a view model here, and in this get to do list. Okay, get to do list is here basically repository.get-to-do-list. We are calling a repository.get-to-do-list, but we can also call a to-do dot get-to-do-list also. But we are not doing that because uh, let's say we have two different things. Let's say we are also getting the list from the offline also and from online also, that as a database backup. If we are getting the list from the online and offline, let's say if your application is connected to the internet, then the list will be fetched from the server, and if we don't have internet connection, then the list will be fetched from the local database. So all this logic we have to write in the view model itself. If you are not using that thing, if you are not using the repository in between this, but if you are using the repository, then this code doesn't change. Basically, a view model only knows about repository. So view model go to the repository, and it will ask, give me a list of to do items. So repository will now take care, the repository will now check if you have internet connection, then we should load data from this to do down, and if you don't have if we don't have internet connection, then we'll load the offline data from this to do DAO, data access object. And if we do have internet connection, then we are going to use the retrofit instance and get the data from the internet. So logic we will write here, and whatever we are dealing with other another file, that dealing with the files, we'll write all the logic in the repository itself. So view model will not be concerned about from where the data is coming. View model just wants data from the repository. View model just query. View model just ask the repository to get the data. Hey repository, give me a data, and the repository will go and do all that background thing, that it will check whether you are in network connection or not, and after doing that, it will just give back the data to the view model. View model doesn't concern about the data, because the separation of layer is done because of this, so that our code should be maintainable. So if such modification which I have just talked about comes into our application, then we will just create a separate retrofit instance here, write our methods there, and uh, we are just going to make change in this method itself. We are not going to uh, manipulate the code in the view model. So this is the benefit of separation of concerns. Because we are using a event pattern here, we only need to deal with the model layer if we are changing the data source. This is basically a loose coupling between the different layers. So if we are going to change from where the data is coming, then we need to only change the model layer. We don't have to touch view layer, or neither view model layer. We only need to change a bit code uh, from the model layer itself. This is the advantage. That's why we have created this repository class. And after this repository, I have already explained the data converters, repository, to do DAO, to database, and to do item is an entity class. I already explained. And here is just small things remaining about the view. So in the to do list, basically when we are clicking on this add new item button, we click on this, we see this dialog. But this dialog, the same dialog can be used when we are when we are editing the existing item. So this data same dialog appears, it just changes its name. Let me long click on this one, and this is the same dialog. I have just changed the title here, edit to do instead of add new to do, and the fields and the options are same. So for that, to maintain simplicity and to um, make it more maintainable, I have created a separate pop-up utils file. In that I am calling this the show add edit to do pop-up item. In this I am passing the to do item and context, and the third one is view model instance. So I'll just go on this pop-up utils. So I have already written the comment here as well. It is just utility class for showing add or edit to do item, and it is a singleton class. As it is object, it has only single instance, and here is the only one function resides here. And in this same function, you can check the code. The code is just if there is already existing item is there, then basically this to do item will not be null. So on long on and it will have some already, it will have already to do item. And let's first understand the case of when there is a new item. So this will to do item will be a null, and it will not go here. Then it will just initialize all the fields. It takes the inputs and it will show the data. And after we click on that, data will be also handled on the basis of this null check. And when we click on set positive button add, we are only going to add the item to the our database table, true item. In this is a view layer, and we have to just call the layer call the layer of view, call the view model for this insertion task. So view doesn't know how the view model is gonna do this thing. View is just going to the view model, and it is saying that absurd to do. So hey view model, please get this data and please add it for me. That is the only thing view is concerned about. View is offloading the task to the view model, and we have just created a separate object of this to the item, and we have just sent this. There is nothing else we are doing here because this is just a view layer. All we have to do is just call the view model here. So we have just called that, and our task for the view layer is completed here. So here and here, as it is a view layer, we are showing the toast messages here. And yeah, that's it for the set negative button cancel. We are just dismissing the dialog. And later, let's now check about adapter. Only one file which is remaining in our explanation, that is TodoList adapter. So basically, adapter is just a thing which provides support for displaying a to-do list in a recycler view. So that is the same implementation which I have already discussed in one of the adapter related tutorial, recycler view related tutorial. And there are different functions, bind, on click view. In this bind view holder function, we are setting on click listeners. So on this check to do, we have just click on just set on click listener. So when check to do is clicked, that particular item will be sent viewModel.mark task completed. So this is also the same thing which we have seen just now. It is just handing over the task to the view model, mark this task as completed, and just sending the parameters, and that's it, we are done. And we are showing the toast matches here. And this is one a delete to do button. So this is a bin button here, which on clicking which we are going to expect it to delete the item. So we are just offloading this task, calling the view model dot delete to do. We are just calling the delete button, delete to do function of the view model here, and that's it. And we are just showing the item deleted toast message here. And here when we long click on the card, so that then this code will be executed. And here we are just showing the pop-up util dot show add edit to do pop-up. So here from the list fragment, we are sending a null in place of to do item, because as it is a new to do item, there is no existing item to get details from. So that's why we are sending it from null here. But in the adapter, when we click on this tile, this tile already has a data. So we are sending the same to do item here, current to do item, which we are getting from get item position of the position on which we have clicked, and we are sending the current to do item object here to that function, and the context and view model instances are the same. And when we go there, the to do item is not null. When it is not null, then it will set the text, basically whatever the task name we have associated with that item. So the task name comes by default, you can see it here. If I long click on this one, my third task is coming by default, written in this edit text. How it is happening? This happening because of this code, new item name dot set text. We are setting the text uh, to whatever the object, whatever the text it was previously associated with this item. So this is set text, and again this is the new item date. So in this date also we are using the date format and setting this date if we have already existing date. So we are doing these things, and other things we are doing as the same. Instead of just this dialog title, in this case it will be an edit to do. Like we can see here, it is a edit to do. And there is again one more difference, small. In case of item added, it will show as item modified in the edit case. And if we are just trying to add items and just show as, please enter all the details. So this case we have just handled that. If there is empty, the both of the text are empty, then we are going to show this, please enter all details. That is a validation we have, simple validation we have applied here. So that is about the project of this to-do list. So for this simple project also, you can see here there are a lot of files has been created. So that may be a bit lot of work, but that will save a lot of hours of work in future when we are going to extend our functionality. So that is about how we have structured the code in our to-do list application, which I have uh, created. I hope that is all clear to you. If you have some doubts regarding this, you can just ask your question in the comment box below. So I will try my best to answer those. And if you still have not joined the TechnoPoints official WhatsApp group, then you can just use the link in the description itself, and you can join there, get the link of the code here, and clone it to your repository, and then again watch this video for better understanding. Also, if you like this video, then please click on like, share with your friends, and subscribe to this channel as well, to so that you will not miss such interesting video. We will meet in the next tutorial with some another interesting topic. Till then, goodbye, happy coding.